In fact, we have asked 4 questions to the panelists. It's not restricted anyhow. The first one is that how do we go forward? For example, the way to, for example, improve the weather prediction capability for the tropical region, for weather or climate. Second one we asked is that are we missing anything, whether in terms of our scientific understanding or in terms of data. This is a kind of a broad canvas. Then having said that, what we should do, like laboratory like NARL, now you know there are laboratories in India. So instead of reinventing the wheel, probably, and also taking the size into account, the kind of people and kind of the freedom we have, what exactly, what niche area we can really address for it. And having said that, is there any possibility of some collaborative work? And of course, this, as I said, definitely this is just an indication, and we said that panelists are free to comment on anything which is relevant to this topic. And I am glad that they have agreed, and we are about full of the panelists will be talking here. Officially, we close at 6:30. That means we have something around. Of course, this clock will not be running because because we are responsible people. So we expect that we will stick to the allotted time, adjusting among ourselves. So if I roughly calculate, okay, even if it take about 1 hour or a little more, so roughly it will come to 5 to 6 minutes per panelist, and then probably after that I will request Dr. Henry to say his remarks, and then probably I will conclude it with some of my remarks from my own side. With that, let me request Professor Richard Renala to have your remarks. You have a choice, or you can come there or speak from there.
So, yeah, we were asked to answer several questions. I'm only going to answer some of them because I'm not in a position to really comment about things like predictability over tropical regions and things like that. I guess one of the things that I would say about this from a modeling perspective, maybe I'll stand up. One of the things I would suggest from a modeling perspective is to try and move from a modeling practice of really playing around with different convective schemes and that sort of stuff at low resolution, and really just try to do some high resolution models that resolve clouds in these kind of problems. I think that Todd Ringler's work at 3 kilometers was showing some real promise, and you can look at some regionally refined models over South Asia and Indian Ocean, and maybe make some progress in that area. But again, I'm going out on a limb because I'm more of a computer guy than a monsoon expert. I do think that another thing is if you're going to do that sort of stuff, you have to have your computing infrastructure aligned with that sort of objective, and I think that means a much greater focus on both parallel computing, on our topic, and data-centric computing. I think that a couple speakers, the Oak Ridge talk in particular, touched on this idea that we need to really try to focus on the ability to do data analysis. You can't do these high-resolution schemes without a very strong sort of data analysis and data mining effort. Okay, so there's a couple comments. And, when it comes to thinking about NARL, NARL has a very similar acronym to NCAR. It's the National Atmospheric Research Laboratory. We're the National Center for Atmospheric Research. It's a very similar thing. I think one of the functions which this conference exemplifies that you really should focus on is, and you seem to be focusing on, I'm not saying you're doing this, but that's, workforce development, encouraging young scientists to get involved in this. This is an extremely important field for the 21st century. We're in a situation where the world is, experiencing climate change. We have a very large number of people in the world that depend on limited resources. And so this sort of modeling of the environment is very important. And I really believe that getting students interested in this particular field is absolutely critical. So what I would encourage you to do is have more events like this, more hands-on training activities, more programs that get students involved. At INCAR, I started a program to teach students computational science. So we have had 100 students go through that program in the last 6 years. And it has really made an impact in the sense that we now have several young modelers and numericists who got their start by going through the SciParks program. And RAM here has mentored a couple of those. And so I feel really strongly about that. And as far as collaborations, one of the reasons I came over to do this conference is to meet. There's a tendency for us to stovepipe our scientific communities, and everything's self-contained. So the Americans maybe talk to each other, but not so much to people in other parts of the world. And I think that's a very important thing that we're doing here. One of the collaborations I'm looking forward to is trying to find people like Mr. Mukherjee, who did GPU work, and exchange views about how to do this and techniques, and those are the kinds of people that I'm interested in developing collaboration. So I do think there's something to work on in terms of accelerators in the next generation of technology, and those are important to develop for a number of reasons, which again, the Oak Ridge perspective is a sort of nice summary of that. We need it from capability perspective and also energy efficiency. I think when you look at the possibility of shrinking a petaflop machine down to one rack, which is more or less where we're headed, you have to do that in an energy efficient way. So that's an exciting thing, at least from my narrow perspective. And finally, I guess the only thing I wanted to say was this has been a very interesting and informative workshop. A lot of different people of different research interests, and I think it's worth repeating in the future. And I would encourage the people to try to have follow-up interactions and maybe dedicate, if we do it again, I would suggest dedicating a weekend day to hands-on training for the students, something like that, so that's kind of blocked out. And then you have more like, rather than sort of sprinkling it through, I think it might work a little better. I've had some experience with that. And then the other part is, I just want to say it's the best part for me, my first time in India. It's an amazing country, and I've been very impressed by the friendliness and hospitality of everyone that I've met. So it's rich.
Thank you. Me too. It's my first time in India, and it was very interesting. And I'm old enough that I've met Indian scientists in atmospheric science often, but the first time I see them in India, in Canada or something. Since the question was fuzzy, I guess my answer would be fuzzy too. For collaboration, Well, a lot of the thing, I tried to sprinkle my talk initially with, I made some remarks that they were really in line with what I think would be important for, let's say, an operational forecasting center to make progress and so on. So, my main, well, I would encourage you to participate in what's called MIT experiment, because there's the experiment going on with Benoit Champagne on comparing dynamical cores. That's why it's called DC MIT. But I was part of a working group which is kind of coordinating the activities worldwide on the meteorological model, numerical modeling, comprising climate, operational forecasting, and data simulation. So that acts like a steering committee for the world. It's a subcommittee of the World Meteorological Association organization. And one of the tasks of the group is to make sure that the development is there, development happens, and the best practice are followed, and the best techniques are developed. And for that they make a lot of experiments which are called by model intercomparison project. So the first one that we have seen during the week was AMIT, atmospheric model intercomparison, or CMIT, couple model intercomparison, and so on. Codex, it's a MIP for regional models, but it's a MIP in the name. So Codex is a very important resource. This is quality control is comparing with the others is an important part of the business. Now you have problems and expertise that others don't have. So you experience convection, studying convection. The first speaker of the conference said, you study cloud, and you probably know more about tropical convection than most of us do. Even though our models are more successful on the whole, it's true that we may not be that successful over the tropics. And also, you have a problem with the Himalayas. We all have a problem with the Himalayas, but you survive. And actually, it's a topic that's very at the edge of development, trying to better represent sea porography in numerical models. Not so long ago, the Himalayas were 3,000 meters now. So because you have to do some filtering and so on. So the mountains are not represented properly. And as I showed, one of the progress of our forecast model was to better parameterize the blocking effect, numerical blocking. So it's still very important topic. And as part of the modeling, there was also the dynamical modeling. There's you have a virtual coordinate that better represents dynamical. So these are two areas where that should be of interest to you and may help forecasting the industry. So I think my opinion is that study is missing the forecasting of the output. That means that this is still an open problem. We should continue to address and also with the international
Thank you. So, for me, it was not quite the first time to India, but last time I didn't see anything from India, so in that sense it was also the first time, and it has been a very good experience actually. The question I got was to say something about future directions and possibilities to go to do research in the future. And from my own experience and also from what I saw in this workshop, especially from today's day, I think there is one particular thing that we are all interested in, but which again became very apparent with the problems here in India, that is the multi-scale behavior or the multi-scale character of most of the atmospheric and physical processes that are around us. And so that is something that is also in particular important here, and that can only be solved by a rigorous physical understanding of the processes together with numerical methods that can cope with those. And so I would propose, and that is of course not completely selfless, because I am in this community, I would propose that if you go forward, you should include, even though it is sometimes a bit difficult, and because those people are a little bit kind of stiff at some point, to involve mathematicians and to involve computer scientists. I can say I regard myself as a computer, because I think it is necessary in order to solve the problems that lie in front of us. Now, I also would encourage you to select only a few kind of challenging problems to work together on those, on the different aspects on those. And you have lots of them, but maybe you shouldn't go to that much diversity change. And Rich already mentioned that. It is good to expose yourself to the international community if it is possible at all. So try to kind of invite experts from the international world, but also try to get chances to go into the international world. That is important. In that sense, I can offer collaboration from our side, CIMA Campus, Hamburg University, Max Planck Institute, and the other institutions around. So if you go to my webpage and then you click on the homepage of the CIMA Campus, you will find job offers, you will find workshop opportunities, and so on. There's lots of things going on. There are already quite a few people from India there, and you might even find some kind of hooks culturally to cope the German culture, which is definitely very different to your culture. Yeah, that there is a possibility, and Hamburg has a large community of scientists in this field. And in the end, I would like also to encourage you to take responsibility for what you are doing, because in the end, we are responsible for, even though we are just researchers, we are responsible for wide-ranging, influential decisions that are taken. And so the results that we produce need to be very solid, and they need to be on a very solid ground. It is important that we adhere to best international practices with what we are doing, that we implement procedures for showing to the public that what we are doing is rock solid. And I'm speaking of personal involvement in that when I was in the tsunami business. I was asked for inundation maps where people in the communities were taking wide and far-reaching decisions on. The international airport of Bali is being newly planned because of inundation maps that we created. So that is an investment that is really something, and you have to be sure that what you are doing is okay and it's really grounded on solid science. That doesn't mean that you are not able to fail, but it means that you need to put all the emphasis in doing it right. And again, validation, verification is very, very important for that, and we saw also the talk on that. And it is also good to expose yourself to criticism, because that helps you to kind of think about whether what you are doing is correct or not. So in this sense, this was not very, very precise in saying, well, you should actually take that model or this model. I can't do that, and I won't do that. But I think these are some things we should think about, and we should all think about, obviously. So thank you very much.
Thanks. This is also my first time to visit in India. I appreciate everything for what I did and what I did. Back to year 2002 to 2003, our group was one of a few modeling groups that focused on high resolution global model with application to specifically to hurricane modeling. At that time, we have been challenged by many people, including program managers, because the high resolution model involves a lot of computing resources. I'm glad that we see that right now high resolution global model becomes a very hot topic. Anyway, based on our experiences during the past several years, we believe the following items are very important. First one, we believe at this stage it is important to understand why the impact of the resolution, especially their impact on physical processes. That's why my talk was focused on the multi-scale processes. And our approach, one of our approaches to examine the multi-scale processes is concurrent visualization. That allows us to examine the transient dynamics of tissue formation and tropical waves. Another area I think is important is model physics. The regional model has been going higher resolution. Regional model has been used in the deep microphysics, and I think the next step, for example, 5 years or even within 5 years, global model may also need to apply the deep microphysics. And at Garda, we have a very strong modeling group led by Wei Guotao. They have been doing this kind of modeling research. And the other area that is part of our future task is we would like to develop a so-called multi-scale analysis. The kernel of the map is the so-called HHT, Hilbert-Huang transform. Compared to the Fourier transform, HHT is a nonlinear transform. It is possible to apply this technique to examine the nonlinear interaction, especially associated with the downscaling and upscaling. And I think the last one is I've been seeing many speakers, especially during this workshop, especially from the local people. They show a lot of mathematical equations. I think another area which might be an interesting topic is to provide a theoretical understanding on the issue of numerical feasibility, such as the Lorentz model. Okay. It is my belief that the butterfly effect showing in the low-risk model may not be totally understood, at least from my point of view. I think it still requires a lot of research. That is the 4 items are in my mind. Speaking of collaborations, I think as long as within our research domains and that can have a future mutual benefit, we are open to any kind of collaboration. I'm looking forward to building any future collaboration with people here. Thanks.
So yeah, my main interest, as you may know, is in the physics area. So I've been very interested, especially focused on the physics talks here, and we see a lot of uncertainties in this region, in the physics. And we've seen the planetary boundary layer, people working on that, seeing what's working best. Land surface is a big area of interest, of course, as well as the convection and the microphysics. And all these feed into the main prediction problem here, which seems to be the seasonal prediction of the summer monsoon, as well as there's local daily forecasts too. And it's nice to see WARP is used operationally in several places in India. WARP was developed, of course, in countries outside of India, so it might have been tuned in some way to non-Indian types of weather. And we'd like to see more of the Indian scientists figuring out what can be done to WARP to make the physics better for this region, because we know the physics isn't globally going to work perfectly everywhere. There are some specific things that happen in this area, especially as the monsoon comes, which is especially challenging to the land model. You have to get the soil moisture development right, and the convection, which obviously feeds back to the land. All those things are very sensitive to both the land and the convection, and you have to have them both right, otherwise you're going to have trouble with any long-term simulation. So I've seen people making good progress here on trying to at least see how good WARP and other models are in these kind of seasonal predictions. I'd like to see more development work now in the physics to actually find ways of making it better here. And I think it takes people in this area to know what's good and what's bad, rather than people from outside trying to come and understand the Indian weather from scratch. So I think we can learn from what you learn as you run the model and try to develop the physics. But we've seen people are not just taking the physics as a black box here, they are actually understanding what's in the physics and what makes different schemes different from each other. And I think the next step after that is, when we found out which ones are working better, to push in that direction and trying to improve them. Convective schemes especially are very challenging, and this is where the grid size issues that Rich mentioned first come in. Ideally, you'd have a big enough computer where you can get away from convective schemes and go down to 3 or 4 grid sizes and simulate convection. You can at least do that possibly as a research tool to help improve convective parameterization. People have done that in other regions of the world. I'm not aware of people trying to improve convective parameterization based on cloud resolving models in the Indian region. So that's something I think there is a fertile ground there for improving the convective schemes based on cloud resolving schemes over India. We've seen, I've looked at the results we've seen here with WARP having all kinds of really bad biases, tidal cycle, precipitation in the monsoon. And we just would like to see what's actually wrong, what can we improve the model, and then that would feed back to us in the WARP development team, and we can improve these parameterizations for other people in the future. We provide development back out to the community as part of our job. So this is the kind of thing that if you can find things that improve the model, we're certainly very interested in getting them into the model for other people to benefit from. So it's not for your own benefit, not even just for the people your friends benefit, it's for the whole global benefit as well, because I'm sure other countries are impacted, local countries especially impacted by similar issues, physics. Another area that I've heard now a little more about is coupling, and this is an area in WARF we're also going into more. We don't have any ocean people in our group, but we are interested in getting WARF more easy to couple to ocean models. Several people have gone their own way. We actually did a survey a little while ago and we found a lot of people already coupled WARF with various methods, various ocean models and other models too, wave models, surf models, and those various models. And they've used different coupling techniques. We've counted 5 or 10 different coupling techniques people have used, but they've included OASIS that we heard about here, and MCC directly, and the couple 7, which is the CEFM coupler, and there are several coupling efforts that I'm sure are going on in India too. But that's one of the areas we want to make it easier for people, is to actually have part of a coupler in the atmospheric model ready for somebody to couple to an ocean model, make the atmospheric model more couple ready. The plug is there, so you just have to plug in an ocean model with the same type of plug. Another thing that's going to come in version 3.5, which we're releasing in end of March or beginning of April, is the hydrology, which we haven't heard much about here, but we're going to have hydrology coupling in WARF. It's done in a similar way to WARF 10, in that it's built into the same executable, and it's a directory you can compile if you want to run hydrology. The hydrology model is developed by NCAR people, so we have the local experts there who can support and answer questions. So interested in going into hydrology, the model is going to be there for you to make it easier in the next few months. I mentioned seasonal prediction. That's an area where we know there's a lot of interest here. How do you do that? You need the ocean. This is where the coupling comes in again. You definitely need an ocean component, a good prediction from the ocean, and then there's data simulation for actually initializing the ocean and the atmosphere, but mainly I think the ocean in the seasonal times there. And I think those are the areas of physics I wanted to talk about, and that's my main area. I'm also in the WMO WRP Mesoscale Weather Forecasting Research Working Group, and our working group is interested in in helping countries to improve their systems and learning from other countries. And there are a couple of mechanisms where that's done. One is through field programs which involve a forecasting component, and it might exist, and we try to encourage international participation in those, which would allow the local people and the international people to collaborate in some way or learn from each other's problems as they forecast for a particular field of concern. So the MWFR does support that kind of program, WMO. And the other thing is, of course, is workshops. We had a workshop in Austria last year on high-resolution complex terrain modeling. WMO they had very little money, but they were able to support one person from Nepal to come to that, and obviously they're interested in complex terrain, and so these kind of workshop opportunities do come up occasionally too. And again, the aim is to benefit from other countries' knowledge and try and improve your own forecast systems with their benefit. I think that's all I have to say.
Yeah, I agree with my previous panelists what they say. So, but I guess especially I feel that we all enjoy your hospitality. My first time to India is a very interesting experience for me. So I will probably try to contribute to this discussion from our perspective. Our laboratory is more like a technology transfer. So we do research in really focus on how we transfer technology into from the research into our operation. So we have this so-called data developmental test bed center, DTC. It has been proven to be very useful. I say more about DTC later. But first, I really want to encourage the young people. This is really the excitement of modeling. I think we are the last several decades, NWC is pretty much quasi-geostrophic, hydrostatic, good at the middle latitude. But for the tropical, it's still we are not doing a good job. But now we have enough computational power. It's possible we can do this non-hydrostatic and globally resolve the tropical convection. I think from the work experience, you can see that if you go down to the 3 or 4 kilometers, convection is really number one. Number two is topography. Topography is really challenging. Even though I come here, I do not see that much focus on topography. I think topography, like we have this technical problem, two terms, the Current transformation term, two terms, different signs. It's a difficult problem. But I see the exciting thing is now I see MPAS has 3 kilometer simulation. SJGF here has 3 kilometer simulation. So I hope in a few months we have 3 kilometer simulation there. That's my goal. And so talk about extend the NWC from the latitude to the tropical. I see there is opportunity for this lab to play. Yesterday I really impressed by go through the laboratory and see how much data you collect, especially in time. Even though it's only 1 point, but in time can provide a really good opportunity for either data assimilation or the model verification. So I think that certainly, like previous panelists, basically 2 important things: cloud convection and orographic presentation is something that we should focus on. And this for our lab, we had a successful DTC experience. What we did is DTC. If you think that you see many papers published, but if you really use to the operation, it's not working. So we have a group of people and then identify a suite of parameterization and a model, and then we start to do it in a real forecast environment and do the verification. And this is how we can identify. Sometimes the methodology is not as rosy as what you read from papers, many of that. And then in terms of this, the data this laboratory has, I think I told people, I say now, last 5 years, you see 5 to 10 years here, big effort on the dynamic core, global cloud resolving model dynamic core. But I think that the next phase you will see lots of effort in physical parameterization. The challenge with global models, physical parameterization, the water vapor coming go out in the limit area model, integrate 24, 30 hours, it does not affect the Earth radiation project. But for a global model, if when we go there, they never go out from the later boundary. So this really gives this parameterization a challenge. And I think your data can be a really good parameterization. After all, is try to parameterize in terms of observation data. And so once a model, a dynamic core is developed, then that it can be used as a carrier to carry parameterization or aerosol. I think the aerosol is going to be an important task focus in the next So I guess, let me see. Okay. So I guess that's all I have. Okay. Thank you. Okay. Thank you.
So I don't want to break the trend here, but there's one point I want to make with slides that I can't make with words. So I did put some slides together here, and hopefully that will keep me on track. I do have some highly biased comments to make. As you might guess, you know, I would strongly advocate you moving toward a global multi-scale modeling framework, not necessarily this one, but some multi-scale modeling framework for your regional climate. So specifically, when it comes to studying the regional climate of India, you can do this right now with the computer resources you have in hand, in a global model, at the scales that are of interest to you. And this is the point I want to make. And I had the privilege of speaking early, so I've had fantastic discussions during the week. And basically, what I heard was, you know, I can't do it. I don't have enough computational resources to run a global model. And so basically, if you can run WRF now at 9 kilometers, and you get a simulation done in a day, you can run a global model with 9 kilometers there, 150 kilometers everywhere else, in a day in 3 or 4 hours. So this modeling framework is accessible to essentially anyone right now who's doing limited area modeling. Now, I will skip this, other than to say, you know, what you get is teleconnections. I mean, we've seen time and time again that to understand the climate of India, maybe more than any other place that I know about, you have to take into account large-scale influences, and you absolutely cannot do that in a limited area model. So I'm not advocating to use any particular model, and in fact, what I want to come across is that only a very few number of models are represented here. There are excellent modelers at AVI, at MPI, at GFDL, at Sandia and NCAR, who are developing multi-scale models to do exactly the same as what I talked about. There are approaches based on variable resolution grids, triangles, polygons, quadrilaterals, nested quads, conforming quads. There are a lot of different modeling approaches out there. We don't know which one is going to be the best, but I have no doubt that one of these models or some other model is going to prove extremely useful in modeling the climate with variable resolution. So what's my advice? My advice is to develop collaborations with one or more of those modeling institutions that are really looking at developing and pressing on this multi-scale aspect of modeling of climate. And these models are new. I have no doubt that they will win the day, but they are new and they will be a bit painful to transition into. And so my next bit of advice is to identify one or two scientific questions and attempt to answer those questions with your traditional modeling approaches and with these new modeling approaches, and begin that process of evaluation and see what works best for your needs. So I'll leave it there. Thank you.
Again, it's my privilege to be in the panel, and I will go through these items, not necessarily in particular order of importance. Dr. Ringler has already highlighted the global high resolution. I think that's the right approach. So maybe formulate a working group of people who are interested, and let's get started now. That's my recommendation. And the other one could be controversial. When it comes to a computing facility, the facility that one would invest in NWP may not be ideal for climate. So it'll be worthwhile to be quite deliberate about it and have some long-term plans. Even though there are advances there, it may be advantageous to get started with a CPU-only cluster, which can later on, one would have the option to put GPU on. There are vendors who have that kind of solution. So the investment doesn't need to be made right up front. The advantage is that you can just start computing when the machines accept it. Whereas for a GPU, I think it's still 2 to 3 years away before they go production. That's my personal opinion, because that's what it has taken us. It's taken us 3 years to come to a point where we are ready to try it in production mode. Now, of course, now the learning curve is not as steep. There are a lot of lessons learned and they are shared, so it may not be 3 years, but it's definitely, I think it's going to be more than a year. Next one, while we talk about modeling, there are ways to collaborate. One is to, as several have already mentioned, to invest in the next generation, invest it sooner, invest it carefully and thoughtfully about it. And it does not simply not use a model like tuning a few knobs, but use them to learn. And combine climate education, where modeling is one of the tools. Still, I believe that the observational data is king. Many refer to the model simulations as, I would take mild exception to it. I'm not totally objected to it. In a generic sense, it is data, but in a sense of, in a scientific sense, observations still rule over models. So observations are very important. So think about planning curriculum, not just in the college or graduate level. Start at the kindergarten level. Start training teachers, get them excited about it, have some reward programs, have competitions, so that the children would be excited. The politicians always love children, no matter how, what their viewpoints may be, but, when it comes to going to presenting awards to children for some achievement, I cannot think of any politician who would object to that. They like this photo opportunity all over the world. So, and also that gets them interested, and weather and climate is something they can get related to right away. The earliest, firstly, I'm thinking in India that it is not exactly a weather phenomenon. It's just a comet which passed by, where my mother woke me up, and in the middle of the night, you got to see this. So, slowly other things started falling in. When I was in college, I was a little ahead of my time in getting involved in solar energy projects. There's a company which is a startup which folded in the 80s because there's not enough support or interest. So, and from that I got into meteorology and atmospheric sciences. So people get started in different ways. So find means and ways to get children excited. I'm sure you probably have schools bringing in children here for excursions. We should probably encourage that and make it an exciting thing for them. There are many ways to get started. But importantly, when it comes to especially higher undergraduate level or the master's or the PhD level, one can be more deliberate and systematic about it. I'm already talking to Dr. Amit there about trying to get started on have a long-term vision, but get started on teaching some of the students or even faculty on how to set up and start running this model, and not wait till we have computational systems. So we can collaborate on it and try to bring the expertise that we have in our lab and NCAR. We can just take a longer-term view. It's not a one-time thing we come and just teach for 1 or 2 weeks and then go away, but think about a 5-year plan. So the lifetime of a graduate student gets started and becomes a postdoc and becomes a professional scientist. So we can incrementally teach them and eventually let them fly and come up with their own research projects. So it's just not merely running the models but it's really understanding what climate is all about and what weather is all about. Invest in data. That's very clear. There's strength here. Obviously, with a facility like this, it's really a world-class facility for data. I do not know what everything else in detail, what's going on, but I have a feeling that there is certainly room to expand, to develop even new programs and strengthen the things that are going on. And one of the things, obviously, which is lacking here is some kind of a federated system to want to share the data. Have a policy, even if the government is not. I mean, I think somebody somewhere has to start. Okay, it could be a policy here and that we'll have the data, let our scientists work on it after 2 years. It's available for everyone. And add value to the data, add documentation, quality control, curation of data, provenance, and do all these things. And it doesn't have to be done for all the data products. Identify these products which are really, really important, which would serve a wider range of community and which would serve a particular science objective, which may be national or international in scope. And find ways of adding value to data. What do I mean by that? It's a simple thing, maybe combining two data streams and correcting the bias in one data stream using another one which is more reliable, because this is the facility you have and you're looking at pretty much the same volume of the atmosphere using different kinds of sensors. Find ways to fuse them together, and so and then or use that to make one data product better. The atmospheric radiation measurement facility in the U.S., the Southern Great Plains and Central facility has a lot of these co-located instruments, and they have a few handful of very high quality best estimate data products. And these are data, and they are reprocessed as we learn more, as the algorithms develop. Then every 3, 5, 7 years, go and reprocess the data, because this is climate data records are valuable and they're going to be useful for generations to come. And then in science there is prestige. There is a principal investigator for data, and certainly there are already principal investigators for data, but give them more visibility and just make people understand how important data is. Along the same line, there may be, this is something I'm not aware of, but I think that from an NWP perspective, it may be helpful to have a reanalysis product for the South Asian region. So just like the North American regional reanalysis, which is better than the typical one that you want, a half-degree one you can get from global reanalysis products, but if it is with the expertise and with data assimilation, with the proper choice of models, I think with Europe collaboration and the U.S. and with proper computing facilities, that could be a good regional reanalysis product, because you see a number of students trying to use this product, but this would give a high resolution product. So that's something worthwhile maybe thinking about. And also a facility like this can also be used to develop, it could be a test bed for model development and to develop new or test physics parameterization schemes. And maybe there's other instrumentation needs to be done, or maybe the measurements have to be done a little differently, but it would be very, very valuable. So it would be worthwhile to put the heads together with especially the Department of Energy in the U.S. With the atmospheric radiation measurement. They have support a number of PIs who do a lot of great work using the measurements that they have, observations. And since I work for the Department of Energy, in our lab we are HPC-centric, and there are opportunities for collaboration. And there is ongoing discussions to have an Indo-US HPC workshop where climate is one of the priority theme areas, and certainly in the top 3. And I'm not sure what the outcome would be, but there is likely to be a meeting. So it will be important to get the climate stakeholders together if that meeting happens, and make sure that from both sides we push and bring in the right kind of people together for this workshop, so that from that additional planning and future efforts. And the the DOE also has this concept, I think somebody mentioned, it could have been Dr. Ringler, the idea of a co-design center. This is looking a little further ahead. What it means is that in order to accomplish a particular science objective, we need hardware people, we need software, we need science people, observationalists, modelists. Bring them all together and just develop the program. And it's a little difficult to get traction because they all come from different disciplines, certainly mathematicians. So learn the language and learn to communicate better and be more effective. So that's pretty much what I have to, and they are not necessarily in any order of priority, but it's stimulating to think about it. I appreciate that.
Numerical model for data is very easy these days. Okay, so what I want to say is, instead of sitting, identifying a few people and starting from scratch, you can actually get big models, global models. And the main point is that you have to adopt the model for our purpose, or the purpose in India. That means you have to tune it, which means we are not using it as a black box. For example, within 5 years or so, these non-hydrostatic models, cloud resolving models, are going to be very, very common for in climate scale integration. So what you need is a kind of a variable resolution global model which can resolve the problem. Thornton explained that in nice figures, and you don't need much of the resources to run such models. So the clouds are so important for monsoon. Monsoon is everything for in culture, for this nice food and everything. The clouds are so important. You need to have a cloud solving model, okay? And for that, you can basically get the model from the other world-class representatives in this model. There's nothing wrong in it, getting a good model. And the only thing is you have to develop the physics for that, so that the people will not make fun of the climate scientists. You predict something, you get something else. So that means the prediction of monsoon or simulation of monsoon is going to be more and more accurate. Okay. One thing I want to comment is the training. I can see a lot of young faces, curious faces. Okay. And for them, there are a lot of opportunities. Again, look up for the conferences and especially training program like a DCMIP. Dynamic Core Intercomparison Project. That was the second one. First was in 2008 at NCAR. The last one was, September 2012. And we are going to have another meeting of that kind in 2014. Okay? And I think you should try to attend that one. This is competitive, but still you should try. At least some of you can definitely attend that. And there are a lot of data, a lot of information of this DCMIP on the web, and please look at that. And I work at NCAR. Luckily, NCAR is not a typical US government lab. Everything is controlled. It is something like a university. We have a freedom to interact with the university without any hesitation. There is no hidden secret there, and the data is available for the public. So when Rich and myself came here, we had some agenda to find some talent so that we can have some future collaboration with the candidates, and that was one of our plans. I'm sure there are very, very smart people, and we are still looking for more people to come forward to have some kind of collaboration in scientific computing, which means not only meteorology, computer science, and applied mathematics, and of course meteorology also. Climate science also. Yeah. Another point I want to make is the quality of the research. India got 1.2 billion plus people, okay? And we publish, from India there are a lot of publications. There was a study in Science magazine that the quality of the paper from India is very, very low, and maybe we are not making that much of effort to make the paper shine. The people should cite your work. That means every research student should have the ambition to get paper, not in the local journals, the international journals, so that you get better visibility and better accountability about your work and better liability of your work. So you should have at least 2 to 3, at least 3 papers, it depends upon the field you work, in international journals before you graduate your PhD. Okay. Anything else I left? One request to the administration side. Okay, I know this is an ISRO lab. ISRO has a lot of secrets like any other space research lab, but this division, especially carrying the atmospheric science, which is open to everyone. There is no secret in atmospheric science. Okay, if there is some program, something comes, and please support from the administration side to make them attend that meeting. There should not be any kind of bureaucratic hassles or bottlenecks. The students or the young scientists should be able to go there. Yeah, that's very good. Yeah, anything else I left? Okay. Again, coming back to the model, and definitely the feature is non-hydrostatic model, global resolution. Monsoon is a global phenomena, it's not a local phenomena, but you don't need to get the 100% of the grid resolution there. You can have a variable resolution, tropically, then elsewhere it's coarse kind of simulation, like the model Thor developed, and so get into that field. That's it. Thank you very much.
Okay, I shall talk from Indian standpoint of view. In India, we have got problems like this day-to-day forecast. Now, Professor Verma has been mentioning number of times in this workshop that the day-to-day forecasts are not coming correct regularly. Of course, this is a fact that day-to-day forecasts are not coming correctly. But this is not the phenomenon only in India, but it is the difficulty in the tropical region. So improvement for that. Secondly, the monsoon forecast, long-range forecast. India has been giving long-range forecast since 1886, more than 125 years. But the skill score has not improved sufficiently. Even though it was started with the statistical forecast, it's still continuing along with that modeling. But when we see the year-to-year forecast, some years it is coming very good, but when the extreme cases are coming, particularly the failure of rainfall or flooding, excess rainfall, in those cases models are not working, neither the statistical model nor the numerical model, NWP model. And third thing is that we need better focus for tropical cyclones, because our eastern coast particularly is vulnerable for the tropical cyclones. Of course, a lot of improvement has taken place in the tropical cyclone forecast, but still we need further improvement. So for this, the answer lies that statistical focus, particularly for the monsoon, whenever the near normal monsoon would be there, it would be all right. But extreme cases, statistical forecast can never be good. So we need really the modeling. But in the modeling, we have to keep in mind that it is not the atmospheric model, the coupled model, atmospheric and oceanic model should be used. And there are a lot of models which already been mentioned. I don't want to repeat that. But we need some improvement, but improvement in this process, the data assimilation should be there, proper data assimilation should be there. And we need better parameterization schemes, particularly land surface, microphysics, these are to be introduced. And I think we should have, as I mentioned, the global model has to be used, because monsoon is not a local phenomenon, it's a part of the global circulation. So global model is the only answer. But it will take its own time because we have to improve upon the thing. Then about the collaboration. Now international collaborations are already been discussed. But I am coming from a university where resources are very limited. and already some collaboration programs are there with in our university and NARL. So it can be augmented further, and of course we can provide some assistance. We can give human resources, we can give some trained students who can help them in their work. And next is the organization of the event. This particular workshop has been organized in an excellent way. In future, such type of workshop should be arranged. But I know it's very difficult. The organization is very difficult, and not only that scientifically, the logistics is a very important thing, and manpower. All these things are needed. But I think it need not be done every year or every 6 months. It can be done at a regular interval of time, which is suitable for the institution as well. And finally, I thank the organizer for excellent arrangement and the hospitality extended, especially to Professor Jayaraman, Amit, Jyoti, and the volunteers. So this much I have to tell. Thank you very much once again.
Good evening. I guess coming at the later part of the panel discussion is good because all the points are already discussed, which also means that I don't have much to talk in the first place. But I feel that there are some hydrostatic approximation, the role of Coriolis component on vertical and role of motion, and when we look at some simple models of MJO, they seem to have, when you include these effects, for example, there's work by Hayashi and Ito in 2012, it shows that it has an impact on MJO. Some models have started to take this into account, and I think more dynamical force need to worry about the fact that we have to look at deviation from hydrostatic, especially when you look at these problems. Even if the scales are coarse, the effect could be important. I know it's a bit controversial, but I think I'll stick out my hand and say that it is important. And even, as I said, we need to look at high resolution and appropriate equations. And one thing when it comes to data assimilation, normally we do not worry too much about rainfall. We look at wind, we look at temperature, but you also need to understand that when we are in the deep tropics, it's the heating because of convection or rainfall which kind of drives the circulation. So there should, whenever we do data assimilation, we need to worry about the fact that our rainfall and circulation should be in good balance. Maybe you could think of techniques where you can take satellite data and ingest it in a very regional fashion. So this basically means that you have to look at modeling, equations, dynamical force, data assimilation, that is all aspects of the model need to be taken care of. And it's a major problem for us is good quality trained manpower. I mean, the youngsters you see could be about 30 to 40% of atmospheric science students in the country, which means that there aren't many atmospheric science students in the country. So we need to increase good quality trained manpower. We have good quality. Now the quantity should also increase as well as with the quality. And we should have targeted training programs which could be considered for modeling in general and dynamic code in particular. And as far as collaborations are concerned, we need to collaborate. We cannot say that we're going to look at monsoons in isolation. It's not an isolated system. So we need to collaborate. I'm talking from the Indian side, and we'll be happy to collaborate with who is willing to help us to improve the monsoon prediction. Thank you.
Yeah, actually, it's very difficult for me to say anything because I'm not a trained atmospheric physicist. I'm only a physicist, really. So, but I will say few things as an outsider. Hopefully, but as a community, I'm very sympathetic, and I really want this thing to succeed. So just flash, well, first really has been a wonderful workshop, especially for me because I really learned a lot of things. So many models, excellent models, and of course excellent talks. But for me, I have no choices to which one to pick and which one to learn. I mean, there's just too many of them, and especially I have to continue in my own field. So, but one thing I'd like to say that at least biannually we could have a workshop. I did talk to some experts, and they seem to be okay to come again, I believe, or of course some other set of people whom we can invite. But of course, the organization is a difficult problem, so hopefully we can arrange this biannually. So, well, I'll just put some what we are far from. Now, this is basically as an outsider, so I don't have any insight into atmospheric phenomena. But large relations which engineers use, can we get some time to that scale and some time to that accuracy? Well, the problem is that some of the physics is not understood. You are rotating turbulence, there are problems. Like we don't know the way, it's not cosmograph. So I believe there's some improvement will be possible. Number of codes I said is very interesting. I had to pick up some of them. What to do? Work towards building computers, especially in India. We need it was told that we are going towards extra, but of course I think we are lagging far behind. And I have a name too for the computer which we could have. Indra is a weather god in India. So, and probably committed. Well, what I would like is compiling a code takes time. So suppose we have a computer where all the codes are compiled, and students can simply log in, experiment on it, a smaller computer. So that kind of thing would be useful, I believe. It just saves time. I mean, the compilation itself takes probably 2 weeks or so. This is what. So I believe. I mean, it was already pointed out. We probably need to interact with all sets of people, and this is, as I said. So I think we should probably. I mean, these are the places where we can interact with international collaborators. The software companies are very eager to set up shops here, mainly for testing and debugging and so on. But I think we can. I mean, we can learn a lot by doing parts of things which are not really code development, but just getting used to the code, learn about them. We really need to get there. India specific, maybe this is something which, since I work on a HPC kind of problem, so we are agriculture centric country. So for us, monsoon is very, very critical. Last year it was a problem for me also, even though I don't grow, I'm not a farmer, but it is so hot, we want the rain to come. And the rain is not coming, the IMD says rain is coming tomorrow, but rain doesn't come. So we should do it better. I mean, for citizens and especially for the farmers. I think we owe it to them that they should be able to get a better prediction. So, and I believe we should probably go, well, ISRO is doing an excellent job in terms of their mission, but we need to get to something like ISRO-like mission for weather prediction and climate modeling. That collaborations, of course, contribute to integrated efforts, need faster machines, and one more, well, there are machines in India, but quite a few of them are only optimally, not used optimally, probably 10%, well, some of them are, I'm sure, less than 50% of the time. But we need some models for research delegation. I think this is important, but of course, here there are a person who is really on the decision making, but we should impress upon them that we get to a place where we maintain the machine very professionally. It's very critical. You may have a pedestrian machine, but there's no machine right now which is allocated based on scaling right now in India. So I think we need to get to that kind of thing, and that's what I have to say. Thank you. Happy computer.
First, thank you for everybody. I enjoyed here very much all your hospitality. I often, this meeting make all the often like a reunion here because we are all doing a dynamic model. And I think we all, they are all give a very good recommendation and give us something for us to think about based on the director's 4 questions. So how to go forward? Then I think we know all of us already suggest we should continue the meeting, and so I think this is a very simple way to say to go forward, because that is opportunity not only for all the scientists outside to get together, to enjoy together, right? No, it's just kidding. It's we can have actually contribute our science. We are actually very willing to provide our what we know to all the young scientists and help each other. Okay. So one of the most suggestion is I think for the young scientists, because during the period of time, most of them come to us to discuss and ask questions. So maybe discuss sometimes it's better just sit there to listen. Because sit there to listen, maybe just pick up some, and maybe pick up long. Okay? So I think that is it's a more suggestion that we can actually improve. And about the continue about the collaboration, I think we may be locally, of course, John, he already left. He say their web has all the information, who is doing what and what is their interest in. We can do actually more active way. We create a web page here, and we ask who is waiting to be the lead, what you are interested in, you want to provide the guidance or whatever for the overseas scientists. They can put all the topics what they are willing to do, they are interested to do and interested to provide help. And then the young scientists here can go up there and to teach. And whether we have a resource or money to travel, this is the next step we can discuss with either the overseas institute and overseas second. So that would become more active way instead of passive, and also help local. And you can have you can collect a lot of scientists, overseas scientists specialty in your lab. Okay, about the model to pick, it will become biased to everybody. But for me, I feel any model is okay. You actually identify what kind of topic you want to do. Pick up one of the model that actually you can use the model to improve. If you cannot find the problem you can solve, maybe you can help the model to solve the problem. You know what I mean? You want to solve a problem, you pick a model, but the model may be good for your problem solving. The model may be not good, so you solve the model problem. You know my point? Okay. So in that sense, actually, it's all good. It's a win-win situation that you not only help yourself, also help the model. And of course, I think for the future, we should go into the long-hybrid model for sure. And there's a lot of things we have to consider. Maybe the next meeting should be emphasizing data simulation or model physics or something else. I think one thing I also want to provide a small suggestion is that if we have say you ask all the dynamic models here, and we are talking about the regional climate. The regional climate has a regional climate problem. So we don't have a regional climate model right here. So for example, I say I already mentioned that the regional climate models, when force all the model or the regional model try to create a regional climate. They are talking about bias. They don't know how to remove all the bias. Because after, for example, they using the analysis data as a base field, and they run 1 month, and their data scale totally away. How can you look at your rainfall, but your large scale is totally away? That is their so-called large scale, their bias, the regional climate bias. So one of the suggestions is the next one talking about if possible. It's not you can find out give a topic, but the topic require for example, the model is the climate model together to discuss, to decide. And what else I need? I think that's about it. Okay, thank you.
So before we formally close the program, I thought I will also let me tell you some of my feelings. In fact, when we send the questionnaire to the panelists, we also ask the same question to ourselves. And of course, your suggestions are well taken. But some of them, which I have wrote it down at that time, there is a good matching in this. For example, the one is typed. I have not written now. So one is that data assimilation, the importance we should give. In fact, we have talked about topography of the place is very crucial. So we felt that, in fact, ISRO is responsible for launching satellites. There is Cartosat, there is remote sensing satellite, and many more data are coming up. So we felt that we should have a good data assimilation scheme. So so that such data can be utilized. So the second point we thought is that to have some parameterization schemes based on the kind of data which is available with us. That's also mentioned by some of you. And the third one is, in fact, as in part of collaboration, we are ready to conduct some special campaigns. In fact, we have did something, we are ready to do that. For example, in a convective event, you know that we have a kind of a 50 kilometer square area, we have the automated rain gauges available. They are collecting the data. We are getting an X-band radar soon. It will be 50 kilometer. It will be scanning. So, in fact, if you have ideas, we can conduct a special focused campaign where all the co-located instruments here are operated in that towards that focused one. That's what I thought, which I have noted down earlier. I will share it with you. With these few remarks, now we are come almost to the end of the program. It was very interesting, and requesting my colleague, Dr. Sharma, to give the vote of thanks. Thank
you. Good evening. On behalf of the local organizing committee of ADCMOC, I am pleased to propose a vote of thanks. At the outset, we are grateful to the members of International Scientific Committee. We thank them for their time and effort in drawing up the program. We also thank them for their continuous guidance through all the phases, from concept to the organization. We are especially grateful to the invited speakers. They have kindly accepted to take out time from their busy schedules and invested efforts in traveling to Tirupati and Gadanki and brought the advanced knowledge of the state of the art to the participants. Many of them traveled halfway across the globe and had to adjust to the new time zone, weather and food. We highly appreciate the kind gesture. We also thank them for kindly accepting the memento. A picture of the memento is shown on the screen here. Peacock is a national bird of India, and one with unfurled plumage signals presence of rain-bearing clouds and the onset of precipitation. We thank the participants for the enthusiastic response to this program and coming over by undertaking long journeys over the length and breadth of India. We hope that they had a rich learning experience over the past 6 days.
Financial resources are one of the most important requirements for any such endeavor as the program. We are highly thankful to the International Center for Theoretical Sciences of Tata Institute of Fundamental Research, Mumbai, and Department of Space, Government of India for generous funding for this program. Finally, we would like to record a deep sense of appreciation and gratitude to all the supporting staff of NARL. We thank them for their unflinching support, even at odd hours before the program, in technical areas, venue arrangements, catering, transport, accounts, purchase, housekeeping, and horticulture. The local organizing committee wishes you all a safe journey back home.